channel. I'm Snehita. My teammates are Yuvarshita. Welcome to our YouTube channel. I'm Snehita. My teammates are Yuvarshita, V. Bhanusri. We are under the guidance of N. Prasad Sir, Associate Professor, Department of CSC, SWEC, Bhimvaram. Our topic is inheriting classes and types of inheritance. So let us discuss about introduction to inheriting classes. In Python, class inheritance is a core concept of object-oriented programming that enables you to create new classes as subclasses based on existing classes known as superclasses. Inheritance allows you to reuse code, establish hierarchical relationships between classes, and introduce specialized behavior in subclasses. The existing class is called a parent or superclass, and the new class is called a child or subclass. In Python, the class keyword is used to define classes. When defining a subclass, you specify the superclass from which it inherits by including the superclass name in parentheses after the subclass name. The subclass inherits all the attributes or data members in the methods of the superclass and can also define its own specific attributes and methods. This inheritance mechanism provides code reuse as you can leverage the functionality of the superclass without duplicating code in the subclass. Benefits of inheriting classes. There are some benefits which include code reusability, modularity, overriding and customization, polymorphism, code organization and maintainability, and as well as encapsulation. First, let us discuss about code reusability. Subclasses can reuse the code of their parent class, reducing the amount of code that needs to be written. You can inherit attributes, methods, and functionality from a parent class, reducing code duplication and promoting modular and efficient programming. Modularity. Inheritance allows you to divide your code into smaller and more maintainable modules. This promotes a clean, organized code structure. Polymorphism. Inheritance enables polymorphism, which means that objects of different classes can be treated as instances of a common base class. Subclasses can be used interchangeably with their parent class. It makes code more flexible, easier to maintain. Code organization and maintainability. Inheritance improves code organization by providing a structure. Classes that inherited from a common base classes are grouped together, making it easier to understand and maintain the code base. Encapsulation. Inheritance supports encapsulation, which means it is an essential principle of object-oriented programming. Encapsulation ensures that the internal implementation details of a class are hidden from external code. Subclasses can encapsulate functionality that is specific to the subclass, while still inheriting common functionality from the parent class. Overriding methods. In Python, you can override methods of a class by redefining them in a subclass. When a method is called on an instance of an subclass, the redefined method in the subclass will be executed instead of the one inherited from the superclasses. Subclasses can override methods inherited from their parent class by defining a new implementation of the method in the subclass. When a overriding method is important to maintain the same method signature, which includes the method name and the number in the order of parameters, you can use the super function to call the overridden method from the superclasses within the super implementation if needed. This allows subclasses to customize the behavior of inherited methods to suit their specific needs. Accessing parent class methods and attributes. In Python, you can access parent class methods and attributes by using super function. Accessing parent class methods. To access a method defined in the parent class, you can use the super function. This super method provides a way to call the parent class constructor, as well as the methods and attributes of the parent class. This allows subclasses to reuse and build upon the functionality of their parent class. In the superfunction, we can also effectively access and utilize methods and attributes defined in the parent class within the child class. Best practices for inheriting classes. Use inheritance judicially. Only use it when it makes sense and add values to your code. Use clear and descriptive names. Choose meaningful names for both the base class and the derived class. The name should accurately represent the purpose and the functionality of each class. Favor composition over inheritance. Inheritance should be used when there is a clear relationship between the subclass and the superclass. If the relationship is not strictly considered, using composition instead. Follow the Liskov substitution principle, that is also called as LSP. This means that the subclass should honor the contracts and the behavior defined by the superclass. Use the super function by overriding methods in the subclass. Call the superclass implementation using the superfunction. This allows you to extend the behavior of the superclass without completely replacing it. Document inheritance method. Rights. Use docstrings to provide clear documentation for the subclass. This helps other developers understand the intended behavior and usage. Avoid deep inheritance hierarchies. Deep hierarchies can become complex and to maintain instead favor a flatter class. Use composition or HF4 to use and not easily. This can make more difficult to understand and maintain. Keep class responsibilities focused. Each class should have a clear responsibility for single purposes. Split functionality into separate classes that can be accomplished or inherited as needed. Trust thoroughly. It means test thoroughly. When inheriting classes, ensure that you have a comprehensive test coverage for both the superclass and the subclass. This helps catch any issues introduced during inheritance or method overrides. By following these best practices, we can create a well-designed and maintainable class hierarchies when inheriting in Python. Remember to consider the specific requirements and constraints of your project to make appropriate design decisions.
Introduction to inheritance in Python. Inheritance is a way to create a new classes that are built upon existing classes. Inheritance is an essential feature in object-oriented programming that allows classes to inherit attributes and methods from other classes. In Python, you can create a new class based on an existing class, and the new class automatically inherits all the attributes and methods of the existing class. The existing class is known as the parent class or superclass, and the new class is called the child class or subclass. It allows us to reuse the code and also to create a hierarchy of classes. The parent class is also known as the superclass, and the child is also known as the subclass. Inheritance provides several benefits such as code reuse, extensibility, and the ability to create specialized classes based on the existing ones. It allows you to define a general class with common attributes and behaviors and then create more specific classes that inherit those characteristics. Single inheritance. Inheritance is the most common type of inheritance in Python. In Python, single inheritance refers to the concept of a class inheriting properties and methods from a single parent class. It is one of the fundamental concepts of object-oriented programming and allows for code reuse and the recreation of class hierarchies. To create a class that inherits from a single parent class in Python, you specify the parent class inside parentness of the class name. In this type, a subclass is derived from a single parent class. The subclass inherits all the attributes and methods of the parent class. Multi-level inheritance. Multi-level inheritance in Python refers to the concept of a class inheriting properties and methods from multiple levels of parent classes. It allows for creating complex class hierarchies where a class can inherit from a parent class, which in turn can inherit from another parent class, and so on. Multi-level inheritance is a type of inheritance in which a derived class is created from another derived class. In this type, a subclass is derived from a parent class, which is already a subclass of another class. The subclass inherits all the attributes and methods of both the parent classes. To implement multi-level inheritance, you can create a chain of classes where each subsequent class inherits from the previous one. Multiple inheritance. Multiple inheritance is a type of inheritance in which a subclass is derived from more than one parent class. In this type, a subclass inherits all the attributes and methods of all the parent classes. It allows us to create complex classes by combining the functionalities of multiple classes. Hierarchical inheritance. Hierarchical inheritance is a type of inheritance in which more than one class is derived from a single parent class. In this type, a single parent class is inherited by multiple subclasses. Each subclass inherits all attributes and methods of the parent class. In
Hybrid inheritance. In Python, hybrid inheritance refers to a situation where a class inherits from multiple classes using a combination of single inheritance and multiple inheritance. It allows a class to inherit both the properties and methods of a single base class and multiple other classes. It is used to create complex classes by combining the functionalities of multiple classes. Hybrid inheritance can be a powerful mechanism for code reuse and flexibility, but it can also introduce complexities in managing the inheritance hierarchy and potential conflicts in method names. It's important to design and use hybrid inheritance carefully to avoid these issues. Superfunction. In Python, the superfunction is used to refer to the superclass, that is parent class, of a class. It allows you to call methods and access attributes defined in the superclass from within a subclass. By using superclass, you can easily extend and customize the behavior of your subclasses while leveraging the functionality provided by their superclasses. It is used in situations where we want to override a method in a subclass but still want to use the method from the parent class. Now, let us discuss about advantages of inheritance. Inheritance is a powerful feature in Python that offers several advantages. Code reusability. Inheritance helps the code to be reused in many situations. The new class inherits all the attributes and methods of the parent class, making it easier to reuse code and avoid duplication. This promotes a more efficient and modular code base. Modularity. Inheritance facilitates the creation of modular and organized code structures. You can define a base class with common attributes and behaviors and then create specialized classes that inherit from the base class and add their own unique features. This modular approach makes the code easier to understand and maintain and extend. Code organization. Inheritance provides a natural way to organize and categorize classes based on their relationships. By establishing a hierarchy of classes, you can represent the real world or conceptual relationships between objects in your code. This hierarchical structure improves the readability and maintainability of the code base. Easy updates and maintenance. When a change or improvement needs to be made in a shared functionality, modifying the base class automatically affects all the derived classes. This saves time and effort as you only need to update the code in one place and the changes will propagate to all the relevant classes. In conclusion, inheritance is a fundamental concept in object-oriented programming that offers numerous advantages, including code reusability, modularity, flexibility, code organization, encapsulation, and extensibility. It enables you to build efficient, scalable, and maintainable code bases by leveraging existing codes and creating well-structured class hierarchies. Disadvantages of inheritance. Inheritance can lead to tight coupling between the classes, making it difficult to modify the code. As the inheritance hierarchy grows larger and more complex, it can become more challenging to understand and maintain. It may become difficult to track the flow of execution, identify dependencies, and debug issues. This complexity can also make the code less flexible and harder to refactor. While inheritance promotes code reusability, it can also lead to some limitations. Inheritance implies an is-a relationship, meaning that derived classes are specialized versions of the base class. Inflexibility in runtime changes. Inheritance establishes the class structure at compile time, which means that the behavior of an object is fixed based on its class definition. It can limit the flexibility to modify the behavior of objects at runtime. If you need to change the behavior dynamically based on certain conditions, alternative approaches like composition or interfaces may be more suitable. Difficulty in testing and mocking. Testing and mocking can become more complex with inheritance. When writing tests, you may need to consider the behavior inherited from the base class, which can require additional setup and context. Similarly, mocking or stubbing objects for testing purposes may require mocking the entire inheritance hierarchy, leading to more complex test setups. It can also lead to the problem of diamond inheritance, in which multiple inheritance leads to ambiguity. Thank you for watching.